In this lesson, we're looking at a different way of talking about probability, and that is odds. Now, it's still talking about the same thing. What's the likelihood of something happening versus the likelihood of it not happening, but it just looks a little bit different. Okay, so we're going to start with the two kind of equations that we're going to reference throughout this lesson, and then we're just going to do a whole bunch of examples, and hopefully it'll make sense after that. So, the odds in favor of something happening are the number of ways that it can happen, so the number of desired outcomes, versus the number of undesired outcomes. And then the other way around, the odds against an event happening, just flip that around. Number of undesired outcomes versus number of desired outcomes. Now, that's probably not going to make any sense in your brain right now, and that's why we need to do these examples. Okay, so here we go. For the first example, what is the probability of rolling a 5 with a die? This isn't talking about odds, it's only talking about probability. So we learned this a couple lessons ago. So if you're looking at a single die, it has 6 sides. We're talking about a regular die, not a Dungeons and Dragons die or something. So it has 1 5 on it out of 6 total sides. So that's our probability of rolling a 5. What are the odds in favor of rolling a 5? Okay, so now let's label this carefully here. This 1 here, this is the desired outcome. That's what we want. We want to roll a 5. This 6 is the total number of outcomes. And if we want the odds in favor, that's this piece up here, odds in favor, we need to know how many outcomes are the desired outcomes. And in our case, desired outcomes, that's 1. There's 1 desired outcome. We also need to know the number of outcomes that are not what we want. It's not the total that we're putting in there. It's what out of the total are ones that we don't want. Okay? So if there is 1 that is desired and 6 in total, that means 5 of the sides are the undesired outcomes, the ones we're not looking for. Okay? So if we're going to talk about it like you win if you roll a 5 and you lose if you don't roll a 5, then you have 1 winning outcome and 5 losing outcomes. Okay? And so the odds in favor of rolling a 5 would be 1 to 5. Think of it like a scoreboard. 1 is a winner, 5 is the loser. What are the odds against rolling a 5? We just flip that around. So the 1 is desired, the 5 is undesired. So these are the winners, these are the losers. And if you're looking for the odds against something happening, you first put down how many are the losing outcomes. It's not always winning and losing, but it's the losing outcomes versus the winning outcomes. So it just flips it around, 5 to 1. So instead of winning on the left and losing on the right, you're starting with these are the losing outcomes and these are the winning outcomes. Okay? That's odds. So where it gets confusing for people is that you can do probability somewhat easily because it's the desired outcomes or the winning outcomes divided by the total, 1 out of 6. But then switching that to odds, you have to think about what are the winning outcomes and what are the losing outcomes, not what are the total outcomes. Okay, so we're going to do some more examples. Here we go. What would be the odds in favor of rolling a number less than 5? So we're rolling a die. What are the odds in favor of rolling a number less than 5? So remember, odds in favor are, I'm going to write it like this, win versus lose. What are all the ways that we can get a number less than 5? Those go there. What are all the numbers that are more than 5 or are 5 or more? Those go here. So let's look at our list. 1, 2, 3, 4, 5, 6. 6 sides, almost stopped at 5. So we're looking for how many of those are less than 5. those ones right there. Right? There are 4 outcomes that are less than 5. And then the outcomes that are more than 5, or 5 or more, that's what I'm trying to say, are those right there. There's 2 of them. So we have 4 winning outcomes, 2 losing outcomes. And so you get odds in favor of rolling a number less than 5 would be 4 to 2. 4 are less than 5, 2 are not less than 5. Okay? What would be the odds against rolling a number greater than 2? So let's look at our list again. 1, 2, 3, 4, 5, 6. I can remember how many sides there are. The odds against rolling a number greater than 2. So we're just going to take our outcomes and we're going to split them into which are the numbers greater than 2 and which are the numbers that are not greater than 2. So here are the numbers greater than 2, and here are the numbers that are not greater than 2. So this is not greater than 2, and this is greater than 2. So what would be the odds against rolling a number greater than 2? Okay, so we want to first put the losing outcomes, and then we want to put the winning outcomes. So we lose if we don't get a number greater than 2. Okay, so 2 outcomes are losers, and 4 outcomes are winners. Okay, so getting a number greater than 2 is a winner. Not getting a number greater than 2 is a loser. So 2 outcomes are losing outcomes and 4 outcomes are winning outcomes. That one's a little bit tricky. And so maybe you can see how this odds thing is going to take some brain power. Please do the practice for this section, okay? It's going to take some work. Example 4. If you flipped a coin twice, what would be the odds in favor of getting 2 tails and then against getting 2 heads? Okay, let's think carefully here. We're flipping a coin twice. And so if you think back to the very first lesson, let's look at our outcomes here. We could get heads and then another heads. We could get heads and then a tails. We could get tails and then heads. We could get tails and then tails. So we flipped a coin twice. Those are our 4 possible outcomes. What are the odds in favor of getting 2 tails? So we're going to look for where are all the ways that we can get 2 tails. And in our case, because we only flipped 2 coins, that's the only one. There's one outcome where we're getting 2 tails. All the other outcomes are not 2 tails. And so the odds in favor would be win versus lose, or desired versus undesired. And so we win if we get 2 tails. So there's only one way of doing that. And there are 3 ways that we don't do that. Okay, so the odds in favor of getting 2 tails would be 1 to 3. What are the odds against getting 2 heads? So let's look at how many ways can you get 2 heads. Well, there's only one way. It's the same thing as before, right? So if we were looking at the odds in favor of getting 2 heads, it would be exactly the same as what we just did for tails. It would be 1 to 3, right? There's one way of getting 2 heads and 3 ways of getting not 2 heads. Okay? But we're looking for the odds against getting 2 heads. So first we have to put all the ways we can't get 2 heads, and then we put the one way that we can. So the odds against getting 2 heads would be lose to win, and that would be 3 to 1. There are 3 ways of not getting heads and 1 way of getting heads. Hopefully this is starting to get a little bit clearer. One more. The probability of winning on a scratch and win at a store is 0.001. And we're talking about the probability of winning any tiny prize. Maybe you'd win $1. That would still count as a winner. Okay, so these odds, 1 in 1,000, that's what that is really I mean, that's the odds of winning, or that's the probability of winning anything. So let's not take that as great odds at becoming a lottery winner. Okay, the probability of winning on a scratch and win at a store is 0.001. So if we wanted to change that to a percent, we would multiply this by 100, and that would get us 0.1%. Not a great probability. Or as a fraction, it would be 1 out of 1,000. Okay, so you should be able to switch back and forth between the different versions of probability, but that's something that we're not really talking about in this lesson. So the probability of winning at a store is 0.001. We're supposed to give the probability of winning. It just told us that, right, in a decimal form. Really what this is asking us for is what would it be in a fraction form. Okay, but we just gave that 1 out of 1,000. That's the probability of winning, but that's the same thing as 0.1%. All of those three ways are valid ways of showing probability. Okay. Finally, what are the odds in favor of winning? Okay, so let's look at this fraction over here. Now this is an important way of doing it. If this is the probability of winning, remember that 1, the top, are the desired outcomes, or the winners, and the bottom is the total. That's how probability works. Desired divided by total, or winners divided by total, whichever way you want to think about it. So if there are 1,000 outcomes in total, and one of them is a winner, how many are not winners? That's the question that you're asking yourself when you're changing probability to odds. So we're still going to use this same thing, win versus lose, or desired versus undesired. There is one chance of winning, and how many of those 1,000 chances are losing then? 999. So if the probability of winning is 1 out of 1,000, the odds for winning, or the odds in favor of winning, would be 1 to 999. Now I'd like to end with an inspirational quote that you see in front of you. Never let the odds keep you from doing what you know in your heart you are meant to do. The odds might seem stacked against you to become a doctor, or whatever your goal is, be the first dirt biker to do a quadruple backflip or something like that. But don't let that stop you, unless you're trying to do a quadruple backflip, and don't do that.